All right, so today we're in lesson 12.1, polynomials. Okay, so what we're looking at is how many terms are in an expression. For example, a monomial has one term. Okay, so you see under here a monomial, one term. So 7x, that's a monomial. A binomial has two terms, so maybe 2x plus 4. Two terms in the expression, binomial. A trinomial has three terms, so maybe this one's 3x squared plus 2x minus 3. All right, so monomial, binomial, trinomial, what is that? It's basically how many terms are in the expression. And then if it has more than one term, I just call it a polynomial. So if it has 4 or 5 or 6 terms in the expression, polynomial. All right? All right, and then the degrees of the terms we'll talk more about in a minute. But to find the degree of a term, we would add the exponents of the variables in that term, even if the variables are different. So you don't have to write these down just yet. We'll go over those in a minute. Just for now, on this slide, you need to write down a polynomial is an expression with more than one term, and you need to write down monomial, binomial, and trinomial, and the examples. All right, so you've got to understand what a polynomial is. You're going to hear that term a lot this chapter. Polynomials, binomials. What are we talking about? How many terms are in the expression? All right, so in example 1, we're going to classify the polynomials. What is this? Basically, is it a polynomial, yes or no? And there's two rules that we'll talk about in a second. And then, if it is, what kind? Monomial, binomial, trinomial. Now, I kind of tend to say that a monomial is not a polynomial because how many terms is it? So that's not more than one. So it's one or the other. However, the book disagrees with me. I don't know. I just say it's a monomial. All right, so here's your two rules, and you need to write this down. This is not on your slide. The first rule is there can be no negative exponents. A polynomial cannot have a negative exponent. If it does, it's not. The second rule is the variable cannot be in the denominator. All right, so no negative exponents, and the variable cannot be in the denominator. Other than that, it's a polynomial, okay? But we just have to figure out what kind. What's the second one? No variable in the denominator. Okay, so does the first example right here, does it meet the criteria? 7m to the negative second power plus 4? No. So I just say no. And really, it doesn't even ask you to say why. What about negative b? What do you think? It's a monomial. So I say monomial. And then it wants us to list the terms. Basically, it's just testing whether or not we can identify the term with its sign. So if there's a subtraction sign in front of it, they want to know that you can recognize that that's negative. So look at the third one, 3x squared plus 8xy minus 1. Polynomial? What kind? Trinomial, because there's three terms. So I say trinomial, and then I individually list the term with the sign. 3x squared, 8xy, and negative 1. So if it's negative, I've got to make sure it's negative when I list the terms. So I want you to try the other three over in the right-hand column. All right, so if it is a polynomial, what kind? And then individually list the terms. All right, so top right, what is it? Binomial. Very good. It's a binomial, and then I individually list the terms. Negative 5x to the third. I made sure that's negative. What about the next one? Nope. Negative exponent. What about the next one? Trinomial. So what would it look like if I had a variable in the denominator? It would be an expression like you see right here in black. 3 over x plus 3, not a polynomial because the variable's in the denominator. Now, could it be x over 3? Yes. It can have a variable, but the variable cannot be in the denominator. All right, we clear on that? Because that's on your homework. Okay, so that's why I kind of just threw that in, because you will see that on your homework. All right, so that's it for example 1, classifying polynomials. Now let's talk about the degrees of polynomials. Finding the degrees of terms. What does that mean, finding the degree? Now, I rewrote these definitions. Now you need to write this down. This is where this applies. The degree of a term, one individual term, is I take all of the exponents in that term and I add them together, of the variables. I take the exponents of the variables. I don't care if the variables are x, y, and z. I add all my exponents together. That gives me the term, the degree of that term. Now, the degree of the polynomial is the largest exponent in the terms. So I take all the exponents of the variables in the terms and I add them together. Whichever one is the highest is the degree of the polynomial expression. All right? Do you see how that works? So even though there are multiple, an x, a y, and a z maybe within a term, I still add all of the exponents together. I know that kind of goes against what we've done in the past, because we've said they have to be the same variable, but not when it comes to establishing the degree of the term. I can add them all together. It'll make more sense in a minute when we go over them. So look at the first one, 8x to the fourth minus x plus 1. How many terms are in that expression? 3 terms, but only 2 of them have variables. So out of the 2 terms with variables, which term has the higher variable? 8x to the fourth, and what is that exponent?
4.
A 4. So 4 is the degree of the polynomial. The highest exponential value in the terms of the polynomial, that's what I go with. But now look at the second one. How many terms do I have in the second one? How many terms? 2. However, with the 5x to the third, y to the fourth, since I have 2 variables with exponents, I actually will add those together to find the degree. So even though it's an x and a y, I still add 3 plus 4 is what? 7. So since that's the highest number, the degree of this polynomial is 7. Okay? So within a term, if there are multiple variables that have exponents, I add those exponent numbers together. Just for the degree. I'm not solving anything or anything like that. I'm just establishing the degree of the polynomial. All right, I want you to try the next one. And I'm looking at 2 terms. B to the third is more, so the degree is 3. Now, what about the next one? Now I have what? Z to the third is the highest, so again, the degree is 3. What about the last one? What would your degree be? 4, but I don't see a 4. How'd you come up with 4? Very good, because within one term, I had 2 variables, 2 exponents. I add those exponents together to come up with 4. All right, any questions on establishing the degree of the polynomial? Okay, you have a section like that on your homework tonight. Now let's get into, probably one of the core concepts for this lesson, and that's writing in standard form. There's 2 criteria for standard form that you need to write down. A polynomial is in standard form if all terms are simplified and if the terms are listed in descending order by exponents, with the number being last, the number by itself being last. All right, so go ahead and write down the 2 rules for standard form are all terms are simplified, meaning I've combined my like terms. We'll talk about that in a sec. And then they're in descending order by exponent. So here's what I'm going to do. In your books, it's going to give it all out of order to you, so you don't have to write it out of order, like copy the original problem. I want you to go ahead and from the book to your paper, go ahead and put it in order, in descending order. So what is the highest exponent that you see there?
4.
M to the fourth, so that comes first. Then any m to the thirds, do you see any m to the thirds? No, with no m to the third, so m squared. Do you see any m squared? Yeah. So since there are actually 2 terms that have m squared, it doesn't matter which one is written first. as long as they're both together, and we'll talk about it in a second, but that also is a reminder that I can combine those terms. All right, any terms with just an m, all right, or m to the first, so that's understood, so minus 8m plus 5. What is important as you rearrange them is that you keep the sign that was in front of it in the original. If it's negative in the original, when you rewrite it, make sure it's still negative. All right, so now let's talk about common terms that can be combined. Now, in the past, we've said, oh, if it has the same variable, like, let's say, 2x plus 3x. What's 2x plus 3x? 5x, because they both have an x. Well, here you say, oh, well, they all have an m, so I can combine them all. Not so. When I'm adding and subtracting with exponents, the exponent has to be the same. So m to the fourth is not a like term with m squared. However, if I have two terms that are both m squared, I can combine their numbers. So negative m squared, well, what's the number in front of that m? A negative 1. So what's negative 1 plus 3? 2. So I can combine them and keep my variable to make 2m squared, and then I just bring down the rest of the terms, and now I've written in standard form. It's in descending order, and everything is simplified. Standard form. So when we rearrange them, what is my highest exponent? X squared, so 3x squared plus 4x squared. And remember, if it's the same exponent, it doesn't matter which one comes first when I rewrite it. I just have to make sure I simplify correctly. All right, minus 4x plus 8. So again, I have terms that have the same exponent, and I combine them. Okay, 3x squared plus 4x squared is, what do I get when I add them? 7x squared. All right, and then I just bring over their others. Minus 4x plus 8. Standard form. All right, go ahead and do the last one. All right, so highest variable first, so 3t to the fifth plus 7t to the third minus 2t to the third plus 6. Is there anything we can combine? Yes. T to the thirds. Did you get that? 3t to the fifth plus 5t to the third? Okay, very good. All right, so that's how we write in standard form. What if, though, we had something like this, and it says write it in standard form now? All right, I know it's small, but it says 3 parentheses 4b plus b squared minus b squared. They are not like terms inside the parentheses. So now I have to distribute, or I have to get rid of the parentheses by multiplying 3 times every term inside the parentheses. Distribute. All right? So 3 times 4b. What would that be? 12b. And then 3 times b squared? 3b squared. Be mindful of your signs. If there's a subtraction sign, you're going to have to make it negative. Whoever's clicking, please stop. All right, and then you just bring down the negative b squared. Now you can write in descending, and you can simplify any like terms. All right, so go ahead now and write it in standard form. All right, so we can combine our b squareds, and what do we get? 2b squared plus 12b. That's it. All right, go ahead and do the second one now. 4a minus 5 times a to the third plus a minus 3. Now we need to distribute first because we cannot add a to the third plus 8. They're not like terms. All right, so now we're going to go, is that positive 5 or negative 5? Negative 5 times a to the third and negative 5 times a. And what do I get? Negative 5a to the third minus 5a minus 3. And now, is there anything I can combine? Any like terms that I can combine? What can I combine? My a's. 4a minus 5a is negative a. And if you said negative 1a, that's fine. Okay, you don't need it, it's understood, but you can write it. All right, one more example. In our last example now, we're substituting and solving. We're making substitutions into polynomials. Let me find it. Where's my example 4? Is this it? Okay, so now I'm evaluating polynomials. So I have some values. X is 3 and y is -2. And I'm going to substitute those values into the polynomial and solve. It really is just a matter of making sure I plug in the correct number and the correct sign in the correct spot. And then my calculator does the rest. So 3 times 3 times -2 minus 7 times 3 minus 2. I just make my substitutions. All right, go ahead and solve that. All right, once I multiply, what do I get? -29. -29. -6 minus 21 minus 2 is -29. All right, let's do the next one. Make our substitutions, and that's an exponent. So 2 times -2 squared plus 5 times -2 minus 1. What do you think is going to be important here? Your exponent, because you are squaring a negative number. Could you do that in your head, -2 squared? Yeah, what's -2 squared? +4. If you put that in your calculator, you're jeopardizing hitting a button wrong. If you don't put it in parentheses, it's going to say it's negative when it's really positive. If I were you, I would just do that mental math. -2 squared is 4. What's 2 times 4? 8. Yeah, you can do that in your head. 8. What's 5 times -2? 10. -10 minus 1. What's 8 minus 10 minus 1? -3. So you have a whole section like this tonight where you make your substitutions and you solve. All right, so you have a few more problems than maybe normal on your homework tonight. However, hopefully it kind of goes quickly for you. This video will be available online if you need it for reference. That's everything you need to know.